When we have a set or a system of vectors, we can classify them as being linear dependent if you can construct one vector from the others in the set using only scale and add. So what that means is if I have a vector that looks like this, let's call that one A, and a vector that looks like this, let's call that B, and one that looks like this, let's call that C. I can construct vector C from vector A and B using only scale and add. What I would be able to do is I might get vector A at the start and I might make it a little bit longer, which is fine because I've scaled it. Vector B, I add to that and I might need to scale that a little bit and I end up, with my vector C. So because there's only scale and add involved in this, that means that this set of vectors A, B and C are linearly dependent. With this scaling, I can also reverse the direction of a vector. So that means when I multiply it by my scale, it would be a negative, and I can do that as well. So anything parallel with this vector would be a scale version of vector A. Anything parallel with vector B would be a scale version of vector B, regardless which way it's pointing. Now, if I have only two vectors in a set, then the only way those two vectors will be linearly dependent is if they're parallel. So if I had two vectors that were parallel, let's imagine they're parallel, A and B, then by multiplying B by a scalar to make it the same as A and reversing it, then my vector B is some amount multiplied by my vector A, and therefore they are linearly dependent. Any other time I have two vectors, if they're not pointing in the same direction, they will be linearly independent of each other. When I have a set of three or more vectors, they are almost always linearly dependent, because when I have three vectors, unless two of them are parallel and I'm looking to make the third vector out of those two parallels, which isn't possible, they will be linearly dependent. Any set containing the zero vector is also linearly dependent. The algebraic definition of linear dependence is that vector C equals some number times vector A plus another number times vector B. And that algebraic definition is one you'll need to know. For this definition, both m and n cannot equal 0. And if you need to find out whether a set of vectors are linearly dependent or independent, and you can solve for m and for n, and them both not equal 0, then you know you have linear dependent vectors. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.